I'm going to discuss about the types of solutions based on Raoult's law. So, what are the solution which follows the Raoult's law? They are known as the ideal solutions. Then, what do you mean by ideal solutions? It has a certain conditions. What are the conditions? So, it should obey the Raoult's law, which means the partial pressure of the solute directly proportional to mole fraction of the solute. Similarly, the partial pressure of the solvent is directly proportional to the mole fraction of the solvent. It not only for the single concentration, for all the concentration it should obey the Raoult's law, but it is practically impossible. So ideally in real situations there are few systems which follows the Raoult's law, but for a certain range of concentration. Okay, so for dilute solution only we consider, okay, when the solute amount is very less, that time the systems obeys whatever you are taking the solute and the solvent system, they'll obey the ideal solutions. And suppose if I'm mentioning solute as A and the solvent as B, both the solute size and the solvent should be same, and both of them have the similar molecular structure, and the intermolecular forces between the solute molecules as well as the intermolecular forces between the solvent molecules and the intermolecular forces between the solute and the solvent molecules should be same, should be similar, the forces should be equal. That is, the intermolecular forces between AA, BB and AB should be equal. And when you are mixing the solute and the solvent, and the volume should not change, so the delta V mixing should be 0. And similarly, when you are mixing it, there should not be heat produced or there should not be losing of heat, so the enthalpy of mixing also should be 0. And finally, the escaping tendency of solute and the solvent should be same as in the solution, should be same as in the pure liquid. Suppose if you are taking the liquid solute, that escaping tendency when you are measuring, that should be same as in the solution as well. Similarly, for the solvent, when you are measuring their escaping tendency, it should be same as their liquid solvent as well as in their corresponding solutions. Okay, and now we are going to see what are the non-ideal solutions. So if the solutions are not following any of the above conditions, for example, they should obey the Raoult's law, but if the solutions which are not obeying the Raoult's law, they are known as the non-ideal solutions. And if the concentration is very high also, it will be a non-ideal solution. And the particle sizes between the A and A, B and B, and A and B, if they are different and they have different structures and they have different intermolecular forces, and those solutions are known as the non-ideal solutions. And suppose if there is a volume change and the enthalpy change happens during the mixing, then those solutions also non-ideal solutions. So this non-ideal solution, suppose if you are defining an ideal solution is follows the like zero line, some solutions deviate. Okay, this is let's say this is negative zone, this is positive zone. So the solution can be, what are the solutions, like the solutions which follows the zero line, we term as a Raoult's law. They are known as the ideal solution. If the solutions are not following this line, so they can undergo positive deviation and negative deviation. So what are the solutions which exhibit the positive deviation? So the ideal solution, the non-ideal solution exhibits the positive deviations are the ethanol and cyclohexane, benzene and acetone, chloroform and CCl4, ethyl alcohol and water. Okay, so if you take ethyl alcohol and water, this is the curve for, suppose this is the mole fraction of ethanol, it ranges from 0 to 1, and this is the mole fraction of water, it ranges from 1 to 0. And when you are individually measuring the pressure, so individual pressure for water and its mole fraction, you get this graph. Okay, similarly for the ethanol, when you just measure their partial pressure and mole fraction, you get this the second graph. So this is the first graph and this is the second graph, and this is the graph that you get for the overall mixed solution. Okay, for ethanol in water, C2H5OH in water. Okay, this is the normal line. Suppose if it is having the positive deviation, mean the curve, this is the curve, it will show it will go above the line. Similarly, this also it will go above the line. Here also it will go above, just above. In the case of negative deviation, the examples of the solution systems are acetone in chloroform, chloroform in diethyl ether, okay, chloroform in benzene, acetone plus aniline. These are the solutions which show a non-ideal solution which exhibit the negative deviation. And when you take acetone and chloroform, this is the graph for the chloroform, this is the graph for the acetone, this is for the overall mixture. And when it shows the negative deviation, the graph will come below. Okay. Okay, so like when the solutions are following the Raoult's law, they are termed as ideal solution. If they are not following the Raoult's law, they are known as a non-ideal solution. These non-ideal solutions are further divided into the solutions which show the positive deviation and the negative deviation. Hope you understood this video. We'll see in the next session.